Dear friends, colleagues, ladies and gentlemen, I would like to welcome you on behalf of the KITION Planetarium Observatory to our online Science Café that we repeat. We used to repeat bi-monthly, now we 2 times a week. Now we do it every month, every last Tuesday of every month at the same time. I'm happy to see very good friends all over the world, from NASA, from our very good friend Danny, who's all day from the States as well, and from all, I'm impressed. Thank you very much for joining, guys. Tonight we have a very honored guest and a close friend, and also a gentleman that inspires me. Dr. Xenophon, Professor Xenophon Moussas. He's going to talk to us about the first ever computer in the world, the very famous Antikythera Mechanism, an artifact that was chosen from Discovery Science and from NASA and from other organizations as one of the most important, if not the most important, archaeological artifact. We are proud that we have 90% reconstruction here at our museum that was submitted by Professor Xenophon Moussas. So I will not take any more of your time. Dr. Moussas, great honor to have you here. The stage is yours.
Thank you very much, all of you, and especially George, of course, for inviting me in this beautiful evening with all of you to present, well, let's say, the history of my life somehow, because since I was a child, I was acquainted with antiquities, I had the habit to visit museums, and as the museum, the National Archaeological Museum of Athens, of Greece, is next to my house in Athens, I used to go there very frequently because it is not only a very nice place, but especially in the summer is cool. So it's a very good place to go even to read a book or a Sunday newspaper, let's say. As Sundays, it was free to visit. And as astronomy was my hobby, it is, well, we are very many of them tonight with the same hobby, I suppose. I had to stop every single time at the end of the journey to observe, admire this item that was called the Antikythera astrolabe. An astrolabe in Greek means literally an instrument that enables you to touch the stars. So imagine a child going there, looking at a lamp of gears made of bronze, almost 100% corroded and destroyed. Four, the largest pieces were in a small window case, and having this name, astrolabe, touching the stars. Probably, in fact, this instrument, because it is an instrument, astronomical instrument, as I studied later, urged me, guided me to become a physicist and then an astronomer. And always I wanted to understand how on earth humans could, well, first of all, cut gears 20-something centuries ago, and even more, to use them for some astronomical purpose. Totally impossible for me to understand, even imagine anything about. And another question, very important one, in fact, is how on earth humans had any interest for astronomy 20-something centuries ago. At the time, there were no telescopes, let alone spacecraft, of course, that they appeared more or less at that time that I was a child. So this guided me, as I said, and when the right time came, with a friend from the University of Thessaloniki, the Aristotelian University, Professor Siradakis, the late Professor Siradakis, and Professor Mike Edmonds, together with his colleague Tony Frith, that has started more or less sometime around 2004. This group that eventually we had the opportunity to study this ancient instrument with the best possible available ways, the appropriate physics with the appropriate mathematics and technology, excellent X-ray beams that are very narrow and they can focus at the appropriate place for us to see through these pieces of corroded bronze and work out the shape, size, the number of teeth of every single gear, and the axle shafts and everything, and especially also the writings, because as all scientific instruments, it has an F1 function, and you press F1 and you have there the explanation of your computer. Of course, it was much more primitive, this F1. It was just two pieces of rectangular copper with tiny 2 millimeters in size, a bit less than 1/10 of an inch, letters. Capital letters are exactly the same as the one we use today. And we started in a year later, in 2005, all this, and a year later, in 6, it was the first article that I suppose really changed the course of the history of technology, mathematics, computing, well, the Greek history, the universal history and civilization, in fact, in many ways, concerning technology mainly. And this is technology, as we will see, that is based on science, the laws of physics that are clearly written in the manual. Another surprise.
Mr. Xenophon Moussas drove my passion for this mechanism. Alexander, can you show what you have next to you until Mr. Moussas and the other,
yes,
on the other side? Yes. So it grew our passion and it became part of our tour here. Thanks to Dr. Moussas. Thank you for that.
Yes, it is an excellent copy of the mechanism. Here we have the two faces of this ancient clock that we can imagine it was like a Rococo clock, working like a cuckoo clock, in fact, with weights and counterweights. we'll learn in a while. And although this is only a reconstruction, I believe that it is very close to what such an instrument, called at the time by the Greeks tablet, believe it or not. Well, of course, it was in Greek, pinakidion. Now, pinakidion means little table. So, tablet, obviously. So this tablet is a double-faced one. And on one face to the left, we see something like a normal clock, together with some lines at the top and bottom. One pointer, the one at the top right, with respect to the center where the Earth is, of course, is the moon. So here is the moon. It goes around the map of the sky, which is represented with the zodiac, with the names as we have them today, with the exception of one of them, Libra, that was slightly different, but meaning exactly the same, having the same name anyway, meaning anyway. And at the same time, we have a calendar that is very similar to the present one, or it is really the Julian calendar, if you like, despite the fact that this has been constructed 100 years before the birth of the emperor, the Roman emperor, that introduced or established this calendar. And at the top and bottom, there are something like 40 lines with instructions that enable the user to use this machine to keep a proper calendar. So when, let's say, this star rises together with the sun, is the 1st of March. Then when this other star rises or sets with the sun, or the other way around, it is the 10th of March. And then there is a line that says, we have equinox, and so on. 40 of them, and they were these 36 stars called decani, decans by the Greeks. And they were, of course, similar in Mesopotamia, I suppose were the same, definitely in Egypt, that everyone can use and know to know what is the exact date today. So this is at the first face of the clock, while the other one to the right has 2 large pointers and 3 smaller ones. The 2 larger ones are with scales that are spiral. In fact, they are mathematically the simplest possible spiral scapes of Archimedes. I mean, they appear exactly like this, constructed with semicircles, half circles, with 2 different centers, and with a step that increases at a constant pace every half, let's say, circle of the spiral. At the top spiral contains what we call metons cycle. It is a calendar that, well, presently we use it for Easter. Christians and the Jews as well use exactly the same, well, with some differences. And it has similarities with also all the Buddhist calendars. The actual names of the months that appear in this calendar that lasts 19 years belong to a family of calendars that appear exclusively in Epirus, northwestern Greece, and Corfu as well. Corfu has exactly this calendar, and Corfu, of course, is northwestern Greece and belong to the same, let's say, set of Greek state cities for centuries, in fact. So probably it belonged to someone that originates from that place, Epirus. Epirus is a very poor region, full of mountains and rocks. And as they have many children, the children go and scatter all around the globe, not only in Greece, but all around the countries. And perhaps a very rich one of them ordered this instrument. This is the only explanation that I can give. Now, this is at the top, this 19-year calendar. Perhaps we'll come back to it. And to the right of the center of the top spiral, we see a small circle, which is the calendar used by the Greeks for the Olympic Games and for the other games as well they had at the time, which are the Pythian in Delphi, Nemean at Nemea, Nan at Dodona, Epirus, in fact, Isthmia, Corinth, and Alia, Rhodes. And to the left, an even smaller dial with 4 divisions makes this 19-year calendar more accurate by repeating it 4 times. So it is a calendar that lasts 76 years. And at the lower part, we have again a spiral, and this spiral with the appropriate pointer that goes around and in fact slides in something like that. It goes forward, backward. Like this is the pointer, goes like this, and as it turns around, it changes circle every now and then. Every circle is 47 months, in fact, and every 47 months, it goes a step outwards, this upper pointer. It's similar at the bottom, where we have the eclipses. The eclipses are repeated with a periodicity of 18 years, 10 days, and 8 hours. Oh, these 8 hours, very odd. And to make it slightly more human, they take the triple of this period that is called Saros. And this Saros gives the law that they use to predict eclipses. The triple period is called exeligmos. It really means the evolution of the motion of the sun and the moon in the sky, in the celestial sphere, in fact. And the small pointer to the right has three numbers. One is 8, the other is 16, and the missing one was 0, obviously. And you are meant to add to the indication in this lower spiral scale 0 hours or 8 hours or 16 hours to predict not only the exact date, but the exact time of the lunar or solar eclipse. And for lunar eclipses, works extremely well, even today. So we can predict the eclipses very well with the mechanism. Well, this is a brief description. As I said before, these 40 lines that appear at the top and bottom that we have just mentioned before read Arcturus, morning rising. Well, then you know that it is this date or the other day. We have autumnal equinox. At the time it was the 8th of September. And one line later it says, when the Pleiades are setting together with the sun rising, it is November 8th, and so on. This type of tables, we call them parapigma. It is a term well used, of course, by the specialists today, but at the time it was a table that was present in every Greek city at the center, in the agora, in the market. And a person, every 10 days, used to go there and change the position of a little peg from one hole to the next. So everybody knows that now we are 10 days later, let's say, and it is as the Pleiades this morning were just setting, it is the 8th of November, and so on. These are the three largest pieces that one can see in the museum today, and also at the time I was a child. Right in the middle, we see the largest gear, which is around 13 centimeters. And these protruding things here, for example, or there, or the holes, are probably the places where the planets were. Well, we are not certain for this, but this is what we believe, or at least this is what we proposed already back in 2006, and I think is still the best position for, for the planets. To the right, we have a fragment with some parts of the Metonic calendar, which is the one we use for Easter, let's say. And somewhere here in the middle, well, not exactly the middle, is the Olympic scale. And we'll return again to the Olympic dial. And to the left, we see here at the top a fraction of the instructions on how to keep a good, accurate calendar. And also a very small part of the zodiac, and which is really a map of the sky. It is, as I said, the equator, the ecliptic, let's say, divided in 360 degrees, obviously. And the year, the Julian year, which was the year that the Egyptians and the Greeks, already from prehistoric times, used. Certainly from the time the Olympics started, but we don't have sufficient time to discuss it now, perhaps another time. Well, it's worth saying that with my Mexican friends from the University of Sonora and a Mexican company, Relojes Olvera, and of course, my university, the University of Athens, and my excellent friends, Professor Perez, Professor Saucedo, and Rodriguez, and also Armando Ayala and Jesus Clemente Olvera, and other colleagues from all these three places. We create a huge monumental clock, like the one you see at the left, that will show not only the position of the sun and the moon as I described, but it will also predict the eclipses and the positions of the planets, as I mentioned before. This instrument works with gears, like the clocks we had before the electronic time, let's say, which means till the early 80s, really, not that far. And that's how the constructor makes the sun, which is these lower small golden spheres, as we read in the manual. It says little golden sphere, which is probably the sun, I suppose. And there is another probably saying little silver sphere, or any other color, in fact, or almost, which is the moon, and we see the actual moon in a while, of the mechanism, I mean, which was half black, half white. And it goes around the Earth in 29.5 days, approximately, changes phases continuously, and, believe it or not, changing with variable speed, following Kepler's law, at least the second law of Kepler, to an extremely good accuracy. The difference is less than 0.2%, perhaps, something like that. Really incredible. The other side has, of course, as we said, the eclipses and the phases of the moon that are predicted with the laws of physics that are written here in the manual. And here we have these laws of physics concerning the eclipses, the phases of the moon as well, and very well also, and here is my friend, Professor Perez, that I see that is in the audience, and we have just mentioned, Raul, the monumental clock. I don't know if you have joined earlier. Sorry for the interruption, but this is my excellent friend, Raul from Mexico.
Welcome from Mexico.
See. And this is the rest of the group. As you can see, the secret word is cooperation that I have here in Greek. At the top is the academic, and well, the second line as well. And then the third are all excellent colleagues that help us to have all these beautiful results that we have tonight. And that's how we established what exactly in this beautiful and very interesting, well, it appeared in many US newspapers 4 years ago, and someone was kind enough to send it to me to present it to you. Of course, thanks are also to the KITION Planetarium and also to my friend George and all of you. But cooperation is really the most important thing, and keep it in mind for all human activities, in fact. Now, a few sentences only concerning the shipwreck, but as it was found in a shipwreck that probably sank around 60 BC. This is the small island, is just a bit smaller than Malta, let's say. It we'll see now on this map, the exact position is here. So here is Greece mainland, Peloponnese, and Crete, and Cyprus is here, where is the KITION Observatory. It was in a huge vessel, probably 60 meters long, 10 meters wide, or something like that. The remains of the ship now are spread in a oblong thing like 45 meters long, 10, 16 in the middle wide, and they are at the edge of a cliff. So probably part of the huge vessel over the years went off the cliff and now is somewhere in the abyss, 120 something meters below. We know that very many similar ones, smaller and large, but this is extremely large, is the largest ancient ship discovered up to now. It was covered with lead. The wood is 14 centimeters thick, really very, very thick. The nails are 30 centimeters, 1 foot, or even 1.5. Really incredible. And all of them, all of these thousands of ships, were heading towards Italy, Rome, and everywhere, more or less. Discovered the shipwreck by Elias, one of the people we see in this very small boat, in April 1900. And a few months later, Elias and the others started again looking there for the rest. Now, this is the captain, more or less. Very beautiful things were in it. This is the so-called philosopher of Antikythera, very expressive. It is quite realistic, in fact, and it's probably Vion, a philosopher from the Black Sea. Also, this very handsome young man, perhaps Paris, we don't know. Some Louis XIV sofas like this one. Well, perhaps someone has sorry, I had to interrupt. A friend was trying to enter somehow. And of course, coins, very beautiful Muranos. Well, in fact, they are not Muranos. They are much ancient than the Muranos we know today. But many treasures that since their discovery, they are in the museum in Athens. And when you come, I will be very honored, pleased to go together at the museum to show you the mechanism on the spot.
I took that tour, I have to confess, and it was excellent. I wouldn't like to leave the museum with Professor Xenophon Moussas showing me around. I really enjoyed every second.
Exactly. Now, in this photograph, we have right in the middle 2, or in fact 4, because there is another couple of gears just below it, that are the ones that move the moon following with the very good approximation of Kepler's second law. Let me now show you these 4 gears that make the moon, this is the moon here, to go around at the speed that varies with the distance from the Earth, and as in fact we read in more than one ancient Greek books, this type of machine predicts the perigee apogee of celestial bodies. Really incredible. When I read this for the first time, that was at the beginning of our study, I thought that it was an exaggeration. And a few months later, we discovered in the mechanism these very 4 gears that give this variable speed and very realistic speed to the moon. This, in fact, is a radiography that gives us, well, an idea of the structure inside. There are something like 30 gears here. Oh, excuse me, let me go back again. And you see these arches. These arches are meant to be in between the gears and the plates of the mechanism so that they do not bend as it works, and as a result, the gears are kept intact in their exact plane without distorting, and of course, in a way that they will continue for long. Another surprise was that the gears are made of bronze, of course, contain a bit of lead for lubrication. Again, more or less something that was not expected, at least from us, although it is a practice that was in use till very recently in when using gears in workshops, to use a bit of lead to make the gears have less friction. As I said, we used computer tomography CTs to study it. And here we have one that presents the gear of the sun, the largest one. And below we see some more gears. And there are, of course, very many of them, but we don't have the time to show them. Let me present you the moon. The moon is this hollow hemisphere here, and the Earth is this rectangular thing in the middle. This is one axis of the moon that turns the moon around to change phases during the month. So this is the moon, and it changes gradually. And here is full moon, let's say. This is last quarter, and new moon, and so on. This is the way it works. The gears that I have just mentioned, obviously, are below this structure. And taking into account all that we have read, I am sure that this machine is the best example of the Greek philosophy, the Greek natural philosophy, of course, based on science, mathematics. Science expressed with the appropriate, every time, mathematics. As Pythagoras, according to Greek tradition, was the first to say something like this. Personally, I believe that this was already known to prehistoric people, probably from the 7th millennium BC or even well before that. I mean, causality and the use of mathematics for astronomy, especially to keep calendars like this one, to predict to define the proper time for the Olympic Games and so on, and predict the eclipses that we have here, for example. This is something prehistoric people already knew quite well, I believe. Well, in this sequence of images, you can see how we have studied the surface, taking 40 common photographs, using a flash that goes around at appropriate places, knowing the XYZ of every flash position, and of course of the object and the camera, we can work out with the mathematics and physics all the details of the surface. We can take off the rust using mathematics, and not only, much more in fact. Here in the middle we have the 4 gears that give the variable position of the moon. And the manual. Right in the middle, we read 76 years and 19 years, and below 223 months. These are the laws of physics for the phases of the moon and for the eclipses. And in other parts of the manual that are not that easy to read as this one, we read all the laws of physics they use for the position of the planets, with all the details, how many days it takes for a planet to go, let's say for Venus, from the furthest point of the horizon with respect to the sun to the time it disappears behind the sun or in front of the sun, all these details. Really totally unexpected. And it gives, the manual gives very many periodicities of the planets that appear for the first time in ancient literature. For example, 462 years and 442 years, which are resonances between the planets, the Earth and the Sun, Venus, for example, and Saturn. So we have half a millennium mentioned in these periodicities. In fact, the period of the Olympic Games, which is, well, we all know 4 years, is not 4 years, but 8, because one 4-year period consists of 49 months, and the next one is 50, and then again 49, and again 50 months, and so on. So it's 49 and 50, repeated continuously. And it seems that they have this from prehistoric times, because King Minos, for example, in Crete, changes every 8 years when he takes a new, let's say, term by his friend Jupiter, as Homer, for example, describes, and not only, many others. And this 8-year calendar is one that was in use even in Scandinavia till the 12th century. And in Crete, according to the tradition, we used to have these human sacrifices every 8th year, 7 boys and 7 girls. In Scandinavia, they had 8 boys every 9th year, which was the first year of the 8-year cycle, and 8 bulls, 8 stallions, and so on. Well, male animals anyway, male young animals. So it's the same thing, pan-European at least. And well, we have this calendar is related to Venus, in 8 years, you have 5 periods of Venus around the sun, as we see it from the Earth, of course, and 99 months. So again, you have a very beautiful dance, celestial dance, of 2 planets, Venus, Earth, our companion, the Moon, going all of them around the sun as seen from the Earth always. We are somewhat egoistic looking from the Earth, obviously. We have no option after all. And another very interesting question is how humans manage to understand all these periodicities. 462 years, incredible. 442, equally incredible. And well, it is because humans started observing the sun and the moon from the dawn of humanity. And especially at the time they start agriculture, when they establish their first villages and towns, let's say, they start the use of land properly. They need calendars, and calendars come, as Plato says, with astronomy, with mathematics, and calendars are, and astronomy in general, are very important for humans to agriculture and for seafaring, going around the seas. And Greece has very many islands, and of course the Greeks are sailors, and they were sailors already, as there are humans, or, well, our ancestors anyway, in Crete, for example, and other islands, but let's take Crete, from, let's say, 100,000 years ago or 200,000 years ago. So they had to use some sort of, well, let's say, knowing how to go around the sea, and not just from one island to another one that is, let's say, a mile away or something like that. And predicting the position of the sun and the moon, that are, again, Plato and others say, the first gods of humans, not only in Greece, but worldwide, Plato says, are the sun and the moon and the planets. So to predict the position of the sun and the moon and the planets is an insult, a hybris. How you dare to predict what your God will do in 365 days, let's say, the sun will come from the same place as it was in Christmas, let's say, time, or whatever. The explanation is given very well by Plato and others also, some of the people that wrote philosophy, including the great writers of theatrical works. Anangi in Greek means the urge, the necessity. So necessity is the most powerful goddess of all, Plato says, and others, and Sophocles, of course. And in fact, it is like this. And observing the sun, the moon, etc., humans understand that there are laws of physics described properly only with mathematics, that the let's say, chaotic at first glance nature can be predicted at times. And today we can dare to say that we have the Big Bang and, well, all this that we are familiar with science today. Let me show you a very ancient observatory around 6,000 something BC and 6,000. Well, the white drawings represent the buildings of an ancient acropolis around 6,000 something BC, let's say 6,500 or 300 something. And the yellow one is a new building, a temple perhaps, or a palace, whatever, around 6,000. The first ones were destroyed perhaps during a war or an earthquake, we don't know. And then it was necessary to have a second generation of buildings. This is in Thessaly, middle of Greece. All the white buildings observe sunrise at Christmas. So during the shortest day of the year. And this means that they already have then a calendar that enables them to keep agriculture in a way that is very productive. So, let's say, planting whatever at the appropriate time. So this is the series. The yellow one that now has disappeared is the second series of buildings. And if we go to another acropolis few miles away from the previous one, again we have the same thing. While the second generation of buildings in this one they are not in my presentation now. They look at the sun rising on the 26th of October, which is the time they start to plant cereals in Greece. And this continues till today, really. Many churches follow exactly the same pattern. This is Ulysses, a sacred city near Athens, and it shows constructions observing the sunrise on the 26th of October or the 21st of November, because probably the climate changed during the time and they had to change as well, or I don't know why. So in Thessaly, for example, we have this 26th of October. So this is the second generation of buildings at the Mini, around 1500 BC. And this continues in Pnyx, for example. which is the ancient parliament of Athens, and then to Odeons and the theaters. This is the Odeon of Delphi. And with my friend, Professor Raúl Pérez Enríquez, and other colleagues, we have studied more or less all the Greco-Roman theaters all around the Mediterranean, from Iberia to, let's say, Syria, and well, really all of them, and also to the Black Sea. And they all follow similar astronomical orientations that enables them to keep good calendars. The same applies for the roads of the streets. This is Piraeus. This is the theater of Piraeus, is different, is oddly placed with respect to the streets of ancient Piraeus. And the reason is because they want to know also other astronomically important risings of the sun. The same in Thessaloniki, and of course the most important theater of Epidaurus and so on. And I suppose here I can stop because we have used almost, well, a bit less than an hour, I guess.
If you want
And
to
time
ask
for questions.
it's really interesting. We may continue.
We have time, you think?
I think it's interesting, and we are all here, all 24 participants.
Very well.
It's really interesting, and I also have some questions in the chat from Mr. Doug. If he asked me to ask you something before he leaves. Is Doug with us at the moment? I think he left. He sent me a message. Okay, he left a question for you. Okay, we can do this at the end. And I also kept another 4 questions here.
Very well. Now, let's go back to the manual. Here we read again these laws of physics that they use for the eclipses and for the phases of the moon. And not only, well, the letters are very clear here. They are almost the same as the capital letters of today. The actual shape of the letters enables the specialist archaeologists to date the instrument, and they come out with a time period between 150 to 100 BC. So, from the shape of the letters, for example, Omicron, O, is slightly smaller than the omega, for example, that has these lines below, or that omega. And this is even smaller. The sigma here, for example, has the 2 lines not parallel as today we use them, but slightly inclined. Now, this means that if we take into account all the letters, the fact that, for example, here in this omega, these 2 lines below, one is inclined, the other is not. Here are horizontal. The alpha has here a straight line, and the sigma is not always far from parallel at the top to the bottom. Here is parallel, for example. What else? The P here. P here is slightly smaller, the right one. And all this leads to 150 to 100 BC. These are the laws of the phases of the moon. Now, this is an actual photograph of the manual. Let me show you how we take off the rust. You see, with this 40 photographs that I told you before in mathematics, well, by the press of a button, I managed to take off the rust here and read very clearly the laws that we have just described. The same here. These are some of the 40 lines that we mentioned. For example, here it says, Iads set in the morning, and Gemini, begin to rise together with the sun. And Eagle sets at night. Then Arcturus sets in the morning, and so on. Here we have some eclipses. One here, for example, and we read sigma, the moon, Selene, for the moon. This is an omega rho together, means hour, ora in Greek. And this is a theta, is 9. So at 9 on the hour, we have during this month an eclipse of the moon. And incidentally, we have an eclipse of the sun, Eta, Ilios. Omega rho means hour, at 9 o'clock again, and so on. While here to the right, we have some descriptions concerning the appearance of the moon during an eclipse. Here it says red moon. Well, we only read half of red. And so on. These are somewhat closer. This eclipse, sigma, omega rho, hour, theta 9. Again, Ilios, omega rho, hour, 9 o'clock. A quick look at the motion of the moon. Now, we've just mentioned that this is done using these these 4 gears, excuse me, that follow an 8-year cycle also. for the octateries that gives the Olympic and the other games. And we see exactly two of these gears to the right. At the top, you can see a pentagon in Greek. Now, why to have it there? It's in between two gears, so nobody will see it ever, except if they break. It is the signature of the constructor. Now, this is the symbol of the Pythagoreans. So, he says, or she says, I am a Pythagorean, i.e., I explain and predict nature using mathematics. The simplest possible way, again, Pythagoras first said, which is Occam's razor, really, and very correct, of course. So with this Occam's razor, or Pythagoras razor to be more exact, the creator of this mechanism, the person that conceived the construction of it, uses the theories in practice, in this case, of Pythagoras, using the appropriate mathematics and physics always, and saying, I am a Pythagorean. So Pythagoras is, if you like, the grandfather of the mechanism, but the actual grandfather is Archimedes himself. And from his book to the right, we have a construction that is exactly the same as the scale of Meton for the phases of the moon and of Saros for the eclipses. Of course, this machine has been constructed somewhat later, so perhaps Hipparchus is the actual constructor of the mechanism. Another very beautiful word that we have read the very first week we started looking at the data inside the mechanism. Here it says, cosmo, of the cosmos. And the next word is kite. So, of the cosmos, well, we don't know what. The eclipse, excuse me. And here we read Chrysoun spherion, the little golden sphere of the sun, probably. Although the term sphere, little sphere, appears many times in the text, many times in the manual. Take into account all these, we say that perhaps this mechanism is, of course, an advanced astronomical instrument, an analog, and, well, perhaps one can classify it as digital computer, worked with gears, and the ancients call it tablet. Difficult to escape from that word, it seems. And of course, it was a mechanical cosmos, a planetarium. And I'm absolutely sure it was an astronomical clock. And as I told you, with Professor Raúl Pérez, we construct, and with the other colleagues that I have mentioned, and also we saw the photographs of them. and with Relojes Olvera, these beautiful 4 meters in height, working not only clock, but an astronomical clock, a real planetarium. Again, here we have the dial of the Olympic Games in this 4-year cycle. And as we said, the first cycle is 49 months, the next one is 50. And probably we had also the planets. This is what I call planetary gear, as I named it back in 2006. 30th of November, in fact, to be accurate. And it's one gear inside another gear. It is as small as a coin of, let's say, €2, something like that. And it is inside another gear, hollow gear, and it goes tangentially inside and reproduces this white curve that I have made for you to see. Another very interesting thing is that it has the number 45. Now, the person that constructed this gear is probably older than the one that wrote the manual, because the M that he or she uses is old-fashioned one, probably 50 years before, let's say, the other one. And a quick look at the periodicities that I have just mentioned. There are 462 years, and the 442 years, 442. The first one is almost 300 synodic periods of Venus. And the second one is 427 synodic periods of Saturn. So we consider this very important. All these results. This is the gear of Jupiter that I have just mentioned. Oh, one of the English groups, the one that is presently at the University College London with Tony Frith and his colleagues, believes that this gear is one of the gears of Venus. And I have discovered that it has a coil below this gear, this one here. We have this coil that we see below the gear. And if one pulls this coil, it turns the gear to be tangential inside and make a pointer, show the position of Jupiter. Now, how I work out that it is Jupiter? If we take this gap, the maximum gap between the two gears, is the distance of the Earth to the Sun. In this scale, and in this scale, this radius is the distance of the planet to the sun. And it comes out to be close to Jupiter, and well, perhaps also Saturn, but not really, because Saturn is quite different. The distance of Saturn is much larger. That's why I say it is for Jupiter. And this is the coil that makes it work, I suggest. Not everybody agrees on this, but anyhow, we have several views of this instrument. It is a very rich one, and every now and then we discover new things. Now, the shipwreck, the archaeologists discovered these very small spheres, which perhaps are the sun, the moon, and the planets. Of course, we are not certain. The archaeologists say that these are the pawns of, let's say, something like chess that the Greeks had at the time. It might be, but anyway, we have descriptions of planets being this this type of precious stones. Now, was it easy to design and construct such a gear? The answer is yes, because they have the appropriate mathematics, they have the books, and here we have, well, just a drawing from a book of Pappus. It's a book written around 400 AD or something like that. There are exact instructions on how to design and cut gears of various types, like this worm gear, for example, and various other machines, and even there are advanced exercises for the students, like this one, that says if you turn the crank once, how many degrees, this or the other, and so on. And if you exert a force of, let's say, 1 pound, 1 kilo, how many kilos you can have here around this gear, and so on. And there are even much more advanced ones. This is, it works with air, and it is described by Hero of Alexandria. Quite complicated, as you see. It is a Wankel sort of engine. I'm sure some in the audience will agree with me. Another very interesting thing is the term aspidisci that appears in the manual. Now, aspidisci means little shield, but in fact, in instruments described by Hero, aspidisci is an artificial target for an observer that uses instruments to measure accurately the height of a star, of a celestial body, of the moon, let's say, or whatever. And they need this type of measurements if they want to use this instrument to find out their latitude. Of course, the latitude is very easy. And also, I say, the longitude. Now, why the longitude? In this machine, we have a good position of the moon using these 4 gears that we have just described before. So if you have appropriate tables, and perhaps that's why the instrument is called a tablet, if you have appropriate tables and you know the exact position of the moon, you can work out, well, approximately, of course, your longitude. And in fact, the maps of that time were very good, really, by today's standard. And
Dr. Moussas, if I may interrupt you for a second, you mentioned that the word Kapodistrian is used also in the manual of the mechanism. Does this mean that if it was used for latitude or longitude, that the machine was actually used as well for navigation?
Yes, yes. Yes. All the other colleagues disagree, but I suppose that as we read in many books, Proclus, for example, these, and not only, in other, well, in various books, including some sort of novels or the romance of Alexander the Great, let's say. Machines like this are described there. And it seems that they are common. Well, they are not as common as tablets today, of course, because they were expensive. But some of them say you have expensive ones, royal type tablets that are made of gold, and less expensive made of copper, even less expensive that have plates made of marble, stones anyway, and less expensive ones made of wood. When I read it for the first time, again, I thought this is impossible. How can you have gears that accurate made of wood? And then I go to Iceland in the National Archaeological Museum, and there I discover not one, but 3, well, fragmented, similar machines to the Antikythera Mechanism, much larger, perhaps 3 or 4 times in size. And they are dated around 1780, plus or minus 20 years.
Yeah.
So
may I add something here?
Please.
Sorry. Having in mind what we learned at school, for example, in our years about gears, all of the people's mind go to the Leonardo da Vinci designs. We had a couple of discussions, you and me, in this subject, and we know that from Da Vinci, these designs, we had the Industrial Revolution and the steam engine as a result of the industrial of the Da Vinci designs, etc. So, do you believe that he copied the ancient Greeks, and do you believe that if this technology was not lost, if this technology was found earlier, or if it was not discontinued, or why we have this gap in time between this Hellenistic period and Leonardo da Vinci to have these advanced machines with gears? Would we have a faster evolution in technology?
Well, humanity, the civilization went forward at higher and slower speeds at times, and even went backwards as well. and there was a fear of technology by many. We have, for example, several decrees by Roman emperors. Diocletian, for example, makes a decree where he says that burn the books of astronomy, chemistry, mathematics. And he continues, because the Greeks will produce gold out of stones and will throw us away. So they were afraid of science, some people, not all. Cicero, for example, is a great admirer of Archimedes, and very rightly. He's my favorite. I believe that there is continuation. The books, although many disappear over time, and this happens even today, the books were there in the monasteries and even hidden under, well, I don't know what. Some of the people in the monasteries were able not only to read, but also to understand. They say for one of the emperors of Byzantium, Leo, I don't remember which Leo, not Leo the mathematician, because there was a Leo mathematician, but another one, I think. We have some descriptions that give his personality or his curriculum vitae, if you like, that they say that he is one of the very few people that understood Archimedes best, the mathematics of Archimedes best. So you have everything from minus infinity to plus infinity, if you like, and it continues. The fact that we have these three instruments with Danish inscriptions, of course, but the inscriptions are really the names of the months and the weeks. In Iceland, proves exactly this, I believe. And to the right, for example, in this image that we have now, we can see this is from Hero. One version of Hero's books published in Venice, 1660, if I remember well, has this construction and shows how such a machine can work using continuous motion. Here, for example, we read by Proclus. Proclus is the last philosopher continuing the ancient Greek tradition in Athens. He says that this type of machines have continuous motion. So they are clocks and they work continuously. And also, he says that you can construct such a tablet that shows the perigee and apogee, and so on. While here, Hero says you have a float in a system full of water, where you also have a ruler with the numbers of the dates or and the months, etc. And you have at the end of a chain, a cork, and you also have at the other end of the chain a weight made of lead. And as the cork starts to move because the water level changes with time, as in the water container, we have a small, let's say, a slow dripping of water at a certain constant rate. Obviously, you use it to make the previous thing, this one, work.
Dr. Moussas, I have received.
So I think that you already know everything about this ancient computer. Well, not really. I believe that I could give a 6-month lecture without you being bored too much.
No, we are not bored. We really enjoy it.
No, I mean for 6 months, not for 2 hours. For 6 months.
May I forward to you a question?
Please do.
Okay, I have received a few questions from several people here. I wrote them down. So, okay. So let me see how can I sort this. Okay, from someone said that some people said before that this could be one of the lost mechanisms of Archimedes, but according to the studies, it doesn't match the date.
Exactly.
Of Archimedes. So possibly Hipparchus from Rhodios, Hipparchus from Rhodes Island.
Yes. In fact, here we have the clock of Archimedes.
Mm-hmm.
He also, he was the inventor of 2 celestial spheres that were mechanical and automatic, described by Cicero and some others as well. These on the right are 3 sections of the clock of Archimedes, but as you very well said that the mechanism is few decades after Archimedes. So perhaps Archimedes made the blueprint of this type of mechanisms, although perhaps not. And other question?
Yes. The other question is that from my friend Doug Edward, he had to leave, and our friend from States had to leave now. So he said, is the mechanism likely to have been unique or one of a number that have been manufactured and used in ancient Greece? And the presence of a user manual seems to indicate it was used by inexperienced people. And I want to add on this, since we had a manual, that it means, of course, for me, that it was not used from the manufacturer. So most probably it was used by someone who actually bought it. Who was this guy? Someone that from the Navy, from the Army, someone rich, someone who was on a trading ship, who was very important to have this kind of technology. And
well, all these really.
Most of them produced.
Well, there were no doubt many or several of them. But as I said, not as many as tablets today. Well, no doubt. Because it was not electronic, and electronics today, thank God, are produced very easily and massively and inexpensively. This was a very expensive one, so only rich people could have it. Of course, the military, as our friend said, no doubt astronomers, philosophers, geographers at sea, because it permits you to calculate the latitude very easily, in even the longitude. And going back to the questions, are there other mechanisms? Well, the one here, the image shows its mold. So it is a piece of stone, a very special stone used in metallurgy to create molds so that you can produce many. This one is of the 19th century BC from Crete. And it looks like a portable Stonehenge, if you like. And it really is. Because if you count the dots around, are the Aubrey holes and this type of things. So, and it is the same era as Stonehenge. This proves that there was a market and someone has spent his valuable time to create a mold to produce many of them. This is the work of Tsikirtsis, Theodosiou, Manimanis, and others. While this one is what I call the French Antikythera Mechanism. It has the same Moussas, the mechanism, the same names, all in Greek, the same names of the zodiac. It is part of a sphere, probably, or a quasi-spherical thing. And this is the Al-Jazari clock, described around 1200. And a similar description is given by Procopius for a Greek building in Gaza. And also a similar one was in the Hagia Sophia, Saint Sophia in Constantinople. Probably made by Anthemius. We don't have the time to discuss it, well, for this, because this Anthemius clock was extremely important. And Anthemius was born and educated in a city, Tralles, in Asia Minor, well, more or less opposite Rhodes, now in Turkey, of course. And Tralles was famous for the construction of automata. So many very complex automata were made, robots were made in Tralles, where he was this Anthemius and astronomer and physicist and architect. I mean, mainly we know him as an architect, but he was really very good in all this.
But we have an example of a robot in ancient times while it was moving with steam, yes, with pressure.
Yes, by
Actually,
Hero.
Hero.
In fact, you mentioned Leonardo. Leonardo.
And this view we are going to say now is related also to a question from my friend, Dr. Christodoulidis. He says from 100 BC to around 1800 AD, there is a huge gap. What caused this loss of knowledge? Destruction of Alexandria Library, maybe?
No, I think it's continuation. Well, of course, we have several descriptions of all sorts of all libraries really. There were many in Alexandria, not just one to start with. There were at least 3 very important ones. And these are really, I mean, the very beginning started with the library of Aristotle. But let me answer your question concerning Leonardo and Archimedes. Mm-hmm. In my exhibition concerning the Antikythera Mechanism, I have a photograph of a manuscript by Leonardo where he presents what he calls Archimedes' canon, and it is a steam canon. Now, from the literature, we know that Archimedes constructed a sort of gun that could throw 100 arrows, one after the other. Well, there are even reconstructions of it. So there is continuation and, of course, improvement. We don't start with electronics during the previous century without taking into account, let's say, the way Archimedes or Newton integrates when we want to calculate some electronics, for example. So we have continuation. The speed changes of evolution, and the number of scientists changes with time as well. But it's always there.
I remember, Dr. Moussas, when you invited me to Greece, our first meeting, when you were presenting in Piraeus mechanism with Dr. Stathiou. I remember that both of you mentioned that you were impressed that when you were trying to reconstruct with CNC laser the gear, actually the laser made a mistake, it couldn't fit all the teeth of the gear together, and you were impressed with how much accuracy these ancient Greeks produced this gear. But in the end, you have realized that it did not affect the operation of the mechanism. Could you explain why that happened? I remember you explained to us no matter.
If we look at the seals made with stone, let's say dated around 2300 BC or 2000 or 1500, some of them are extremely accurate. They have divisions all around the periphery that are extremely surprising for us to see them there. But they had very, very good people working in their workshops. And it was a very reputable to be a seal maker, for example. The father of Pythagoras, we know that he was a seal maker. And that's why he was rich and he could educate properly his son and send him in good schools, for example. They were very, very capable already from prehistoric times. The metallurgy is very advanced already around 1500. The alloys they use are very impressive. And not only the alloys, the way they cut them. there are recipes that they tell you how to construct a file. There are saws up to 3 meters made of copper. That's why they survive, or bronze, in fact. That they are made around 2300. Very impressive, all these. And they are capable to construct large things. That's why they need, let's say, these saws that are almost 3 meters long, 1 or 2 of them. Very expensive, of course, extremely expensive. Copper at times was more expensive than gold, very rightly. We will all agree.
And on that shipwreck, if I remember well, when you showed me the exhibits at the Archaeological Museum of Athens, there were many bronze and copper statues. And the very famous one that was, there is a debate if it was Zeus or Poseidon, if I remember well.
Oh, that was from another shipwreck.
That's from another shipwreck, okay. But this shipwreck had a lot of
this shipwreck, we have 2 of the most beautiful Greek statues, yes. One is the so-called youth of Antikythera, or epheb. Probably is Paris presenting the apple to Venus, or Perseus holding Medusa, or a young man holding the Antikythera Mechanism in his hand.
They were made from bronze or copper?
Bronze, yes, yes, bronze. Very well made. And also this philosopher, the head of the philosopher that we saw before, was in the same shipwreck. One of the most expressive faces.
We have one more question from Dasos Christodoulidis.
Yes.
Did the Antikythera mechanism take into account the precision of equinoxes due to Earth's wobble axis with a period of 25,772 years?
We have in the mechanism these little holes that you mentioned that are one next to the other. And these are in a ring that you can transpose, rotate at will. Perhaps this is related with the position of the stars, because when I saw a reconstruction of the Prague clock in a small town of Slovakia, not the original which in fact is not the original, because it has been destroyed during the Second World War, from the war, obviously, and reconstructed, but not according to the original design. The original design has a ring that is identical to this ring with the 365 or 360 holes. Now, I suggest that, as I saw in the Slovakian or the new construction of the Prague clock in Slovakia, in these holes you have stars, and these stars are the stars mentioned in the 40 lines of the mechanism. So when you see this star rising together with the sun, is the 10th of November, let's say, and so on. Now, you can turn this ring and also the ring with the stars with respect to the mechanism. So you can change the position of the stars to take into account this change over the years. And this was known by, well, this has been discovered by Hipparchus at the time of the construction of the mechanism, more or less. I know that nobody will agree with me that this is possible, but we have these holes there, and we have this Prague clock, the original design, that is very close to the design of the Antikythera mechanism with these very many holes that can be turned around, taking into account the precession of the equinox, perhaps.
Anyone from the audience have any question? You may ask directly, unmute yourself, and you may ask any questions. Mr. Jim, unmute yourself and you may ask the question. We cannot hear you, Mr. Jim.
Who is talking?
Can you hear me now?
Yes.
Yes, thank you. And thank you for an excellent talk, Dr. Moussas. The question I have is that there is inbuilt in the system of the mechanism the ability to determine the obliquity of the orbit of the moon. Is there a similar mechanism for what would be seen to be the obliquity of the orbit of the sun from a geocentric viewpoint?
Well, I don't know really. I'm not absolutely sure that I understood correctly your question. Please repeat it. If
Yes.
there is a mechanism, an indication in the mechanism.
I believe that the mechanism has the ability to replicate the obliquity of the orbit of the moon around the Earth.
Yes.
Would there be a similar mechanism for the obliquity of the orbit of the sun as seen from a geocentric point of view?
Yes. We know very well that they knew all these details already from the time of Plato. So centuries before the mechanism, because at that time, the Greeks, Plato, Aristotle, for example, used a different model for the prediction of the position of the planets in a way that could give their longitude and latitude, including the sun and the moon, much better than the epicyclical models used in the mechanism. At the time of Plato, they used a series of concentric spheres, and for every planet, they have one sphere that rotates to take into account the Earth's rotation around the sun, another sphere to take into account the rotation of the sun, of the planet around the sun, and also one more sphere to accommodate for the change of latitude of the planet over its period. Now, this is at the time of Plato already. 27 spheres, one inside the other. They go up to almost 50 spheres at the time of Aristotle, so in less than one generation, really. But this model cannot account for the variation of the brightness of the planet. Then they changed to a model where you add circles. In the mechanism, we have many numbers concerning, in the manual, not in actual gears, taking into account the motion of every planet very accurately. But although we can envisage ways to reconstruct these concentric spheres, probably the spheres of Archimedes, and it is depicted now at the right, this Archimedes sphere. The Archimedes spheres repeated over the years in medieval times and afterwards had these concentric spheres or orreries with inclined and variable axis over time, as you mentioned. The only equivalent for the sun is perhaps a view expressed by the University of Thessaloniki, Professor Siradakis, the late Professor Siradakis and his colleagues, that the gear I say it's for Jupiter, it is in fact to accommodate the variability of the distance of the sun to the Earth. And it reproduces, and they believe rightly, the equation of time. So the change really of the length of the day during the year, which is the result of the ellipticity of the elliptical orbit of the Earth around the sun. So this is an explanation, well, a model for that beautiful gear that, as it is not attached to any other, we have the, the freedom to have several explanations, including Jupiter and Venus that I mentioned for the Frith group at the University College London. We have these, let's say, possibilities. They were aware of all the motions of the orbits of all the 5 planets going up and down the ecliptic plane. And the very fact that it predicts eclipses, also it has the inclination of Venus orbit, if you like, but not directly. I don't know if this is an answer to your question.
Yes, thank you very much. Excellent and amazing technology that they had in those days. Amazing.
Yes. The impressive thing is that at a certain moment they understand that you can work out mathematics automatically, I mean, to have a division or multiplication using 2 gears. And although fragmented, it is already described somehow in Aristotle's, in one of Aristotle's books.
Thank you.
I want to comment something.
Please.
Well, I connected not to at the point where Professor Moussas presented the work we are doing here in Mexico with a monumental Antikythera Mechanism, but I want to give thanks to him for this mention and to inform you that the process of building the first steps, the one-to-one scale mechanism with including the planet is going on its way, and we have already done several advances in that machine. The next step is to work it when it is working. We are going to have some adjustments, and then we are going to the big one, the monumental one to be built for here for Hermosillo, Sonora. This is a comment I wanted to give to you. And also, I wanted to mention that another time, Professor Moussas mentioned that we are working with the theaters, and we are proud to have found, as I understand, several design criteria that were used to make the dimensions of the theaters, including the orchestra and the theatron, the orchestra, the theatron, and the scene, using a simple gnomon as an instrument for making the decisions of the size, following the movement of the sun along the year. And we are preparing the publication for this. And well, only I want to mention that this was done also with several people on Universidad de Honduras and also the Universidad de Athens, Professor Papaspirus and Eduardo Rodas. And thank you, Xenophon, for including our perspective in this talk. Interesting talk.
Thank you, Raul, and thank you all, of course.
Thank you, Mr. Raul, for joining. Great honor for us. And also our friends from the United States, US Eastern Time, and our friends from Australia, which is only 5 o'clock in the morning there. Thank you very much, all guys. It's a great honor for us. These online science cafes unite the world. It also matches to the motto for Astronomy Without Borders, for which we represent CYPRUS, called One People, One Sky. So, Dr. Moussas, thank you very much for the excellent presentation. One more time, as many times as I listen to your presentations, I always listen to you more and more and more and more. It's a never-ending story, because I always I work like a sponge, absorbing data and information, and you know how much I like to spend time with you, talking around for hours.
Mutual.
It's a great honor to have met you and cooperate. And thank you also for the reconstruction that we have here. It's a great honor, and hopefully this time of the so-called pandemic ends soon, and we meet together face by face, and also some other friends that I miss so much, like our friend Astrid and John Fox, and the Western astronomers there. I miss them so much. I hope we meet with all of you soon, and why not travel together to Mexico?
See.
See. So guys, thank you very much for joining tonight. One more time, thank you, Dr. Moussas, for the excellent presentation.
Thank
And
you.
Alexander, if I may share,
we should ask to
screen.
stop sharing this screen to Professor Xenophon Moussas.
Thank you, Alexander.
Thank you.
So before we close, I would like to invite you to our next Science Café. Our next Science Café, it will take place on Tuesday, the 29th of March. We are going to talk about women in science. The lecturer will be astrophysicist Eleonora Kaiser, who is also one of our first two women analog astronauts, and actually the first analog astronaut from CYPRUS who participated in a mission in the analog astronaut training center of European Space Agency. She gave to us a couple of lectures before, one from the actual analog training center with the other analog astronauts of Europe, direct connections, and now she was online with us earlier. I'm not sure if she's still with us because she was in a meeting in Greece. So she's going to give a speech regarding women in science on Tuesday, 29th of March, 2022, same time, 8 o'clock UT+2. So guys, thank you very much. You may use this Zoom meeting ID and passcode all the time. If you logged once, you don't need to log again. It's safe on your PC. Just press the link from our website, astronomycyprus.eu. I have included this earlier in the chat, and you may also please subscribe on to our YouTube channel. All our online Science Cafe are there. We post them there. This one is going to go there soon as well within this week. And thank you very much for joining.
Thank you all again.
Thank you all.
Good night, everyone.
Good night, everyone.